related to information we have about rolling the ball down a ramp. If the ball travels 12 domino lengths in 6 cycles, then our average velocity is 2 domino lengths per cycle. That's fairly obvious. I think everybody completely understands that. Now, the question that was asked for the homework was, how is the final velocity on that ramp going to be related to the average velocity? Well, the ball started from rest. So, if the velocity versus time is linear, if velocity is a linear function of time, then the velocity versus time graph will start at the origin, since that's where the velocity was 0, and move along a straight line to some point that represents the time and velocity at the end of the ramp. And if that's the case, for reasons that we aren't going to detail right now, but it's fairly obvious, then we can conclude that the final velocity is going to be double the average velocity. And just in summary, that's just because the average velocity is going to be the velocity at the midpoint of this interval, and clearly the velocity at the end point of the interval is twice the velocity at the midpoint. Okay, well, that's going to be 2 times the average velocity, which is 2 times your 2 domino lengths per cycle. That's 4 domino lengths per cycle. Then we ask the question of, well, okay, at what rate, average rate, is the velocity changing? Well, the answer to that question is fairly straightforward. We take the change in velocity and divide by the change in the time. That's what we mean by the average rate of change of the velocity with respect to time. So, change in velocity, well, starts at 0, ends up at 4 domino lengths per cycle, and the time interval is 6 cycles, so that 4 6 is 2/3, and we have domino lengths over cycles divided by cycles. Now, that's going to give us domino lengths over cycles squared. So, this is the average rate of change of velocity with respect to time. Now, that is easily identified with this graph. Okay, the time, as it turns out, is 6 cycles, so let's see, 6 cycles, and the final velocity is now 4 domino lengths per cycle, so that between this point and this point, the rise is 4 domino lengths per cycle, the run is 6 cycles. So when we divide the 4 domino lengths per cycle by the 6 cycles, we're dividing the rise of this graph by the run, getting the slope. Therefore, the slope of the velocity versus time graph is the average rate of change of velocity with respect to time, and we have a name for that. That is average acceleration. And that's what we mean by acceleration. The reason we expect the velocity versus time graph to be straight line is because, well, consider a free body diagram, very crude diagram. I drew it right at the end of class, and it's not very well drawn, but we have the ball on the incline. We have its weight, gravity pulling down on it, and we have normal force up this way. The normal force is equal and opposite to the component of the weight that's perpendicular to the incline, but the component of the weight that's parallel to the incline is unimpeded. There's no other force. There's a tiny bit of frictional force in this situation, but we can pretty much ignore that, consider it negligible. And in any case, it's constant. It tends to be constant. So we get a constant force accelerating the ball down the incline. And then if you believe Newton's second law, that implies a constant acceleration and a straight line velocity versus time graph, worth storing away.